Hello. So on this slide, we're going to do the future value of a single sum. So calculate the future value of a $300 investment at the end of 10 years if it earns an annual compounding rate return of 8%. So here are the inputs that you would put into the calculator. The first things you're going to have to calculate is the amount of times it's going to be compounded. So we see 10 years is going to be N. The interest rate is going to be annually compounded, so that's going to be 8%. Since we're calculating the future value, we are given the present value, which is a $300 investment. In the calculator, we're going to have to put a negative sign in front of that. And then after that, we're going to have to put 0 for the payment. And then we click future value, the button future value, and that's going to give us a total future value of $647.68. Okay, next slide. Again, present value of a single sum. Here we're going to be given a discount rate of 9%. So 9% is going to be our interest, the interest button. The future value is going to be $1,000. And then N is going to be 5 years. So we're going to put 0 for payment and calculate the PV, which is going to give us $649.93. Of course, once we do that, it's going to have a negative sign in front of that, but we can ignore that. That's just showing that that's what is inputted and then versus what we take out. Okay, so another example. In this example, $5,000 grows to $575,798.47 over 3 years. So here in this, we're going to be calculating interest. We are given the present value, we're given the future value, we're given the number of years, and we're giving the no payment. Payment's going to be 0. So we're calculating interest. So PV is going to be 5,000. FV is going to be this number right here, 5,798. And then our N is going to actually be 3 times 2 because this is done on a 6 monthly basis, which is just semi-annually. So that's going to be 6. Our payment's going to be 0. And then we're going to compute, and then we're going to get an interest rate of 2.5 for this semi-annual compounding. Okay. This is just showing us the series of even cash flows. So here we have ordinary annuity, where the cash flows are made at the end of each period. So we're going to be using N mode for this when we have examples of this nature. So N mode. And then annuity due, the payments are made at the beginning of each period. So for this, we would have to use beginning mode. Future values of ordinary annuity dues or ordinary annuities. So what is the future value of an ordinary annuity that pays $150 per year at the end of each year, at the end of each of the next 15 years, given the investment is expected to earn 7% rate of return? So here, 7% is going to be our interest rate. We're going to have 15 years. Payment's going to be 150. And then 0 is going to be our present value. We're going to calculate future value. And since it's an ordinary annuity, we're going to be using N mode. and that's going to give us a computed future value of 3,769.35 cents. Okay. So next, we're going to do present value of an ordinary annuity. So again, we're going to be using the AND mode for this one. So we're going to be calculating present value of an annuity that pays $200 per year at the end of each year. At the end of the next 13 years, given a 6% discount rate. So interest is going to be 6%, and is going to be the 13 years. Payment, and this one is going to be $200. Our future value, of course, is going to be 0. So that leaves us the last available section to calculate or compute, which is going to be present value, which comes out to $1,770.54. And this just shows this amount actually here represents the amount of money that an investor would need to invest today at a 6% rate to generate 13 end of year cash flows of $200. Okay, more examples of ordinary annuities. Top one, 10-year, $10,000 annuity, interest rate of 5%. What is the future value? Since this question is asking for future value, we're going to be we're given the present value here. So actually, let me correct myself. Since we're doing ordinary annuities, we're going to be using payments. So in this example, present value is going to be 0. Here, $10,000 is going to be our payment. We have our 10-year for N, interest rate 5%. Once we put that and compute for future value, we're going to get $125,778.93. Okay, for this next example, we have a 12-year annuity with a future value of $180, interest rate of 5.5%. What are the annual payments? N is going to be 12. Interest rate is going to be 5.5. Here, future value 180,000. Okay, present value is going to be 0. So we're calculating our payment in this one. Once we compute all those inputs, our payment's going to come out to $10,985.26. Of course, that's going to have a negative sign in front of it. That's just showing that that's what we need to input to get this future value of 180,012 years. Okay, next one, how many payments of $4,342.65 to get a future value of $60,000 at 7%? So we're given our payment, we're given our future value that we want to reach, our interest rate, we're going to be calculating the number of years. So N. So we know our interest rate, it's going to be 7%, payment's going to be payment's going to be 4,342.65, and of course that's going to have a negative sign in front of it to get our future value of $60,000. We're going to compute for N, and that's going to give us 10 years, or 10 payments. What interest rate would result in a future value of $50,445.05 over 7 years with annual payment of $5,000? So in this one, we're going to calculate the interest rate. That's what it's asking for. So we're given the future value of $50,445.05 over a 7-year period with annual payments of $5,000. That's going to be our payments, right? So our payment input is going to be negative 5,000. That's what we're going to be putting in. for 7 years as our N. Our future value is this one. We're going to compute for interest rate, and that's going to give us 12. Next slide, the future values of an annuity due. So in these previous slides, we were doing ordinary annuities. Now we're doing annuity due. So we're going to be using begin mode. Here we just have a timeline to help make it easier to visualize. So future value is calculated in the final period. That's just showing us that it's going to be at the end of the period, not at the beginning, right? So 6-year, 200 annuity due, interest rate at 8%. So here, $200 annuity due, the end with an interest rate of this. So it actually at the beginning. So under begin mode, we have our N, which is 6 years, our interest rate of 8%, payment $200 with a negative sign when we're inputting it into the calculator. Our present value is going to be 0. We're going to compute for future value and end up with a total of $1,584.56. And then last slide, present value of an annuity due again. So again, begin mode on the calculator, compute the present value of a 4-year $1,000 annuity using a discount rate of 6% where the first payment is received today. So under begin mode, we're going to do a 4-year interest rate or a discount rate of 6%. Payments $1,000. When we're inputting into the calculator, there's going to be a negative sign in front of it. Future value is going to be 0. Compute for present value. And then we're going to end up with a present value of $3,673.01. Okay, so I hope you learned something. Thank you.